Hey, good afternoon, everyone. DJ Raoul keeping it cool once again. You know what I'm saying? No pain, no gain. You know what I'm saying? Yeah. All right. So basically, doing another lesson today. Our lesson would be definitely coming from the measurements, right? We're still continuing on what we did last week, where we looked at, I believe, we looked at length, and all those information we'll see coming up on the screen. Uh, in a short while. So let's there we go. All right. So these are our units and measurements or quantities. All right. Now, if we should do a review, you can see the review in the previous video though. However, today we'll be looking at what you're seeing on the screen here, the fundamental units and quantities. All right. Now, this is something that it's very common on the exams. As a matter of fact, uh, it's you would say on 100% of the exams that you'll be doing, especially end of term or end of year, definitely these questions will be asked one way or the other. All right, you might see them as a multiple choice question, or you might just get them to fill in the blanks in a table. Usually, that's the common way these questions are asked. No, guys, on the screen there, what we're seeing here, 5 fundamental quantities and 5 units beside them. Beside each unit, you see a symbol right here. All right. So the length is measured in meters, the mass is measured in kilograms, the time is measured in seconds, current measured in amperes, and temperature measured in kelvins. All right. So just to reiterate that the basic quantities do include what you're seeing on the screen there, length, mass, time, temperature, and current. All right. Now, if we could just lower that volume. All right. What I wanted to look at now, guys, is actually this is a track that was made back in 2015. The song is entitled Basic Units. All right. So this was produced by DJ Raoul, and at the time, I think it was RK3 Records, but I wanted to hear it. The song is entitled Basic Units, right? And the audio quality is not the best, so forgive me there. But certainly we'll be playing this song, and we'll be talking you through the what the song is trying to say after this. So let's go.
Measured in seconds, the SI. When things get hot, it's called the temperature. The Kelvin scale is the right measure. Ampere per current is a shot pleasure. These are the basic things to measure. Left by time, temperature. Electric current, all measure. Units are centimeters. Left by time, temperature. Electric current, all measure. Units are centimeters. Teragiga, mega, all the prefixes. Cento million or power of 10 to the 12 we call terra, 10 to the 9 we call mega, 10 to the 6 we call mega, 10 to the 3 we call kilo, as in kilo, you know what I'm saying? Yo, time, temperature, electric current, all measure, basic units are centimeters, easy to do like mass time, temperature, electric current, all measure, basic units are centimeters. Things are measured in kilograms. Tick tock, the time goes by. Measured in seconds, the exercise. And things get hot. We call it temperature. The Kelvin scale is the right measure. Ampere per current is a shot pleasure. Yo, these are the basics.
All right, let's stop in it there. All right, so guys, this is yeah. So that song was recorded 6 long years ago. When this topic was taught to some students by yours truly. All right. Now the song basically goes on to tell you that, well, length, mass, time, and temperature, electric current we all measure. Basic units are simply these, easy to know like bun and cheese. All right. That's the chorus. All right. So, and then of course we go into the verse, you know, which says quite a bit about the other stuff. So length, mass, time, and temperature, electric current we all measure. Basic units are simply these, easy to know, like bun and cheese. All right. Length and distance measured in meters. Mass of things are measured in kilograms. Tick tock, the time goes by. Measured in seconds, the SI style. When things get hot, we call it temperature. The Kelvin scale is the right measure. Okay. Ampere for current is a shock pleasure. These are the basic things we measure. Okay. Length, mass, time, and temperature. So that's the words of the song. So I'm saying no, we can know the basic units by using melodies to let it stay in our memory a little bit longer. What you're seeing on the screen here are the prefixes. So also the second verse of the song went on into the explanation of these. Tera, giga, mega are the prefixes. Kilo, centimilli are a few of these, and it goes on to say tera is actually 10 to the 12. So bringing up that on the screen, you should see what the prefixes mean. All right, there you go. And that's almost rhymes a while ago. Yeah, but definitely there you're seeing the prefixes nano included. But giga starting here, giga mega. So giga mega. So we start from tera, but tera is not here. Tera is 10 to the 12. As you can see, giga is right here on the screen as 10 to the 9. 10 to the 6 we call mega. 10 to the 3 kilo, as in kilometer. Yeah, and then of course we have our centi right there, and we have our milli as well. So these were mentioned in the song, and even though the recording it wasn't the best at the time, using very outdated equipment, but nowadays we have more modern equipment that we could use to record better songs. But this is the concept that it is trying to bring to you. So let it not be said, you students in grade 9 at Bellefield, that an effort hasn't been made to bring the information to you in a way that you can relate to. You can ask your questions, you can subscribe to my channel, and you get all of the information that you need to even pass CXC. All right. So we have many different activities that we can use. I mean, I am I would say by a side job would be a producer, and I do some recording as well. So I will use whatever resources I have to bring across the material to you guys. So basic units, yeah, forgotten song, because 6 years ago, it was recorded, and so hasn't been used in any classes. But I just figured that it could at least if you could pick up the words from it, you could learn something. I'm gonna play it one more time, and of course, just remind you that the basic units here, the basic quantities, are length, mass, time, temperature, and current. Let's play the song one more time for you to get the concept. All right.
The time goes by, measured in seconds, the SI style. Things get hot, it's called the temperature. The Kelvin scale is the right measure. Ampere per current is the shock pleasure. These are the base of measure. Temperature.
All right, so stopping you there. Yeah, so All right, guys, we're back. All right, so now, so in this segment now, guys, we just want you to understand the concept here. We're gonna focus on length here, and if we can zoom in on the screen here, what we're seeing here, length is a type of measurement, and according to this, it tells us how long or wide something is, and usually the length refers to the longest side of an object, especially if we're measuring, uh, you know, objects that have various shapes. And in a shape where one side may be longer than the other side, and the length is the term given to the longer side. All right, or the longest side, depending on how many sides it have. All right, so in this visual here, you're seeing a giraffe here, certainly spanning some distance along the ground that's horizontal, but vertically, it's a very tall creature, perhaps the tallest of all. But certainly this is it. The giraffe is most known for being tall, not necessarily being a wide creature. Perhaps an elephant would be wider in spread than the giraffe. But um, this is a giraffe here, and then what you're seeing here, this is looks to be a canine member. Could be a wolf or could be a dog, maybe of the husky breed or whatever. But then the length of this dog, this canine looking creature, is where the red line is, right? So it's the longest side. All right, now there's some questions at the side, and I expect that these should be easy for you to calculate here as grade 9 students. A snake was 35 inches long. No, it is 57 inches long. How much did it grow? Basic questions, just to see how you subtract and add measurements here. Ribbon was what's this? It's 50 centimeters long. After cut off some of it, as 37 centimeters was left. How much was cut off? These are questions that, okay, you're gonna say this is easy. Yeah. But we build from this. We're definitely building on this. Questions related to length would ask you to, well, maybe calculate and to convert. So you could see questions where, all right, you say 50 centimeters, but then how many meters are there in 50 centimeters? The thing about this is, and let's just go on to the other side here. Uh, the units of length, it comes into play here. Definition of length as the distance between 2 points. Certainly, that is explaining. So this basically is a wider definition. So between any 2 points is a length, but then we said before that length usually refers to the longer side of an object when we're taking that measurement, and that is indeed true. However, we still we still technically can refer to length in these words. You are using these words, so words like thickness and height and depth, these are words that could be used. So you should be seeing that information we summarized in the screen there. All right, length may also be called width, thickness, depth, or height. Right, these are words that you'll see in exams that mean the same thing as length. Length again, measured in, well, you have long units and short units. So this units of length here, longest distance measured in kilometers, definitely more common. Short distance is centimeters and meters. But again, I must emphasize that the SI unit for length is in fact the meters. All right. So here's the concept, guys, right? So the SI unit for length is the meter. So quite a couple of things you guys should learn from this lesson so far. And would one would be what length is, all right? And of course, before that, that length is one of five fundamental quantities. I could say basic as well, fundamental quantity. All right. Quantities, remember, are the things that we measure. The unit is the standard that was mentioned in the previous lesson standard used to measure things is in fact called units, right? And you have the SI units. So let's put SI in front of this on the screen. These are our SI units. All right, so there we go. All right, so our 5 SI units, but length is the first one. Looking at different variations of length. Length can be measured in kilometers, and 1 kilometer is the same thing as 1,000 meters because kilo means 1,000. One of the things we will learn. A shorter distance now where we have cm, which stands for centimeter. Centimeter means well, we divide, actually it's meters um divided, so 1 meter divided into 100 parts. That's what it really is. And then a millimeter is 1 meter divided by into 1,000 parts. So why would we want to divide a meter? Now the question is, how long is a meter? Meter is gonna be spread in this way. If I could, all of it won't fit in the frame, but a meter is pretty much from the tip. All right, so the tip of a hand and all the way up here, it's about a meter. See, it's a meter. So the chest here to where the tip of our finger is, definitely should be seeing that. All right, so that's 1 meter. Now I divide that into 100 parts, I get what we call a centimeter. So much so that if you want to know, like 2 centimeters is like the width of your finger. All right, if you can see it closely, the width of a finger is about 2 centimeters. In fact, 2.5 centimeters are an inch, and we will mention that inches are an well, they are a former unit, former popular unit used for to measure um the length of something. But then the SI unit came, the centigrade system came, you know, in our modern time, and then we stopped using inches and well, people still use miles, but inches and miles were part of a older system. I believe we call it the imperial system, which has its roots in Britain. Well, remember Britain used to control Jamaica, so we had to adapt a lot of their traditions because of that. So hence we have this concept here to live with. But then nowadays we are using the CJ. Well, this is the SI unit system, centimeter grams scale here. But then we have 1 meter divided into 100 parts, just like how we have $1 divided into 100, which would give you cents, right? It's 100 cents in a dollar. But unfortunately nowadays we don't use cents anymore. Jamaica's dollars devalued so much that, well, cents are worthless. The only cents we have remaining in Jamaica, and even that is going away, is the 5 cents that we were created with. All right, now it's very shocking that that's the situation, but reality is that that's what's happening. All right, so when you divide 1 meter into 100 parts, we call it a centimeter. And I'm going to write that on the screen. That's a centimeter. And then, of course, when 1 meter is divided into 1,000 parts, we get what we call a millimeter. All right. Meter, remember, meter can be spelled two ways. Even Americans spell it this way. As well as the British would spell it this way. So let's go. So we decide which one, and then I don't think they should take away marks for you spelling it and in the British or American way. That's all I knew. I just spell things freely, so anything, any word or letter that my pen writes first, that's the way I'm gonna spell it. So it doesn't matter. So if you see me using them interchangeably, British and American, I'm just freestyling there. All right, guys. So that's it. All right. So with that said, I don't know if you have any questions, but at grade 9 level, we want you to get a good understanding of the SI unit here. And the last thing before we leave is this. Is actually this. It's which is the prefixes that we use here: the nano, the micro, the milli, the centi, the deci, the kilo, the mega, and of course the giga. All right. Important to know this chart and know the symbols and the meaning. Notice that for centi we have divided by 100. Yeah, Just like how we divide the meter into 100 parts, we call it centimeter. So the division took place there. And for a milli, it's again we're dividing by 1,000. So uh, this now is is a way to write it. We have what we call standard scientific notation. Now, why is this true? Why is so? It's like this: 10 and we have here. We have like 10 to the 1, and we have 10 to the 2, and we have 10 to the 3. What we have here are called powers, are indices. So these numbers here are powers. So the 1, the 2, the 3. All right. So in other words, we have a 1 and we have a 0, and they are given powers. They are given powers. In fact, you cannot even have this. We can have 10 to the 0. So we can have a 1 beside a 0 without any power. And that results in a number that we are familiar with. We are not familiar with we are not familiar with 10 to the 0, 10 to the 1, 10 to the 2. That's not everyday stuff. We are familiar with 10 to the 0 is the same thing as saying 1 followed by no zeros or 0 zeros, which is 1. We are concerned with value. All right, we are concerned with value. So the value of 10, we call it 10. It's really 1 0. If we get into the technology age and we understand how computer work, it's just ones and zeros. So we call it 10. Not necessarily 10, it's 1 and 0. Okay, so now the 10 written like this, 10 to the power of 0, or with the indices of 0, is the same thing as 1. Why? Because this way in which it's written, um, we call this scientific form, scientific notation. Um, all right. We have a standard form as well. Referencing scientific notation is a shorter way. All right, it shortens. So it shortens how large or small numbers are written. And the reason we're doing this is that we can go back to the previous slide and we will understand why these numbers, nano is 10 to the minus 9, micro is minus 6, milli is minus 3, but yet we have kilo here, which is 10 to the third power. You could read this and say it's 1 followed by 3 zeros, going back to the other side here. So 1 and a 0 with no power gives us the value of 1, because the 0 here is telling us that the 0 is doesn't have any power, so therefore why is it doing there? So just forget it. So we just write on 1. All right, hope everybody's understand what's happening here, which means that the next number here is 10 to the 1, and that would be well, a 1 and a 0 given the power of 1. A 0 has 1 power there, which means that okay, it can stay there only once. So the value of that is 10. No, the same thing. No, the next one is 10 to the second. So, well, that's 1. The 0 can stay there twice. So, right, 100. It's a little way to remember it. And 1 followed by 3 zeros there is 1,000. So, that's one way you can understand the whole scientific notation here. So, your grade 9 students can understand this. And my question to you is this. All right. And I'm gonna leave you with this one. All right. Write the value. All right. Of the following powers of 10. All right. All right. So, and then of course, remember that the values are given names. So the powers of 10 are given names. All right. So if we go back to the previous slide, we'll see that okay, 10 to the 6 has a name. We need to know those names. All right. So let's go back to this now. And the question is, and it's gonna be like 3 questions here for you to do for your assignment here. All right, we're gonna add 10 to the 4, 10 to the 5, and 10 to the 6. Also, ABCD as well, 10 to the 9, and also 10 to the 12. All right, let's put 10 to the 12 there. All right, a bonus one now would be 10 to the, of course, I'm going to give you this one, 10 to the minus 1. What does that mean? All right, so guys, this is where we're going to leave it. You should be able to do these, at least the first 5 out of the 6 here. You should be able to do it. All right, guys. I hope you understand what's happening. If you have any questions, you can of course text in the group, grade 9 students, the 3A and the 3B group. All right, and when you do that now, you will get a response once I've seen it. So this now is the activity for you guys. Remember, guys, length, mass, time, temperature, electric current, we all measure basic units are simply these. All right, let's go over those basic units again. Don't forget that one. All right, basic units here: length, mass, time, temperature, and electric current, guys. Don't forget those. So we will come back to these in the next class. And there you go. So all right, guys, so thanks for being here, thanks for joining me here, and I'd like you to enjoy the rest of the day. And I'm going to take you out with this song, Basic Units by DJ Raoul. Okay, stay tuned.
Measured in seconds, things went fast. It's called the temperature and Kelvin scale is the right measure. Ampere per current is the shock pleasure. These are the basic measure.